All right, so welcome to our first video notes for distance learning, and our topic's going to be energy, and we are going to be talking about the basically two kinds of energy. And so if you would like to open up the note guide that's attached to this on Schoology, please go ahead and open it up. You can type directly on the Google Doc, or you can print it and handwrite it, how best you will fit for you, how you want to take notes in class. So we're going to talk about what energy is first. So the energy means it's the ability to do work or to cause change. So the more work you do, the more energy you're going to need in order to do that work. So the two types of energy is called kinetic energy and potential energy. So if you look at this picture of this person holding a red ball, if you hold it up in the air above the ground, you can see she's off the ground. It has potential energy. It has the potential to do work. Then if you see that she dropped the ball and the ball is falling, that ball has what we call kinetic energy. So let's talk about kinetic energy first then. So when you think of kinetic energy, I want you to think of the object is moving. So it's energy of a moving object, an object in motion. And so it really depends on the mass of that object, and it also depends on the velocity of that object. Remember, velocity is just speed in a given direction. So how fast is that object in motion? So there is a mathematical equation, and we'll work on the math tomorrow, but just to show you that kinetic energy can be calculated. It's 1/2 times the mass of the object times its velocity, but then you note that it's squared. So we can kind of write the formula like this. Ke stands for kinetic energy, and then equals 1/2 over m times v squared. Don't forget about that squared. Now the unit for kinetic energy is what we call joules. So all energy is kind of going to be what we call joules, and we use a J to represent that unit. And so one more quick thing about kinetic energy is, remember, velocity is speed, and so it makes a bigger impact on the kinetic energy of an object than the mass. So even if you really have a heavy object, if it has a crazy amount of velocity, it's going to impact kinetic energy way more than its mass. Right, so potential energy, think of it as it has the potential to work. And so the energy of the object is, first of all, it's not on the ground, but it is also not moving. So it has the potential. And so we do have a mathematical formula for potential energy. It's mass times gravity times height. And there's your formula kind of in letters. So PE stands for potential energy, mass, and then gravity. And gravity, we had learned in this previous unit that it's 9.8. So you'd always put a 9.8 since we're dealing with Earth gravitational pull, and then times the height of how high the object is from the ground. Again, the unit is joules, so it starts with the J. All right, so just looking at how do you know if an object is in potential energy or if it's in kinetic energy? How do we know if that object's energy situation? So what you have to ask yourself is some questions. So you see this ball, it goes up in the air and it goes down in the air. So when is the ball in kinetic and when is the ball in potential energy? So we have to ask ourselves, is the object moving? If the object is in motion, then yes, it's going to have kinetic energy. If it's not moving, then there's no kinetic energy. So then if you answer no, there's no kinetic energy, well, then you have to ask yourself a second question. Is the object off the ground? If the answer is yes, then it has potential energy. So it's not moving and it's off the ground, then it has potential energy. But if it's not moving and it is on the ground, then it has nowhere else to go. And so then it would have no potential energy. All right, so looking at kind of the transitional component of when an object moves into potential energy and when it moves into kinetic energy and so on, we look at this picture of a roller coaster, and this should be on your notes. So when an object is dropped, its potential energy turns into kinetic energy. So you can see at the top, this this roller coaster has not moving yet, and is at the very top of the height of the roller coaster. So it's got 100 potential energy and 0 kinetic energy because it's not moving. Now, as soon as it begins to go down, you can see that there is a conversion here. The potential energy is switching into kinetic energy. And then when it reaches the bottom, that's kind of where its fastest point is. And so you could see that it has 100 kinetic energy now and 0 potential. And then it's going to keep moving up, and then that transition again happens. So let's just kind of take a guess and kind of review the difference between kinetic and potential energy. So looking at this picture of this girl pulling back her arrow, do you think it is potential or do you think it is kinetic? Well, you have to ask yourself, is she moving? Is it above ground? So the answer would be it's potential. She is pulling back, but she has not yet let go. So that is the potential energy. And then this is a picture of a baseball player hitting the ball. So is that kinetic or potential? So you ask yourself, well, is it moving? And it is, so it would be kinetic. All right, so let's practice one more time. All right, so I want you to see if you can write these correctly first. So pause the video and then see if you can guess which ones are kinetic energy, which ones are potential real quick. All right, so a bicyclist pedaling up the hill. Well, it's moving, so it's kinetic energy. A volleyball player spiking a ball. Well, it's moving, so it would be kinetic energy. The chemical bonds in sugar. Well, they have the potential to break and release energy, but they have not done so yet, so that would be potential energy. Holding a stretched rubber band. It was kind of like that arrow. If you hold the rubber band and you hold it and stretch it out, it's not moving yet, so it has the potential to do work, so that's potential energy. A bowling ball rolling down the alley. So rolling means it is moving, so kinetic. An archer with his bow drawn, remember, we already talked about that one, potential energy, has not moved yet, has the potential to do work. Baseball thrown to second base. It's moving to second base, so it has kinetic energy. The wind blowing the leaves. Well, the leaves are moving in the air from the wind, so that would be kinetic energy. Sitting on a tree branch. Well, you are on a tree sitting above ground, but you're not moving, so you have the potential to jump off, and so that would be potential energy. And then bowling ball sitting on the rack. So before you begin to roll the ball, it's sitting there. It's above ground and it's just sitting there, but it has the potential to move, so we call it potential energy. All right, so what I would like you to do now is go into today's date, formative assessment, and answer a few questions based off of the notes we just talked about. And please use your notes for support. You do not have to do it on your own.